Okay, now we have the question that says that you have to determine the values a, b, c for which the function fx is continuous at x equals to 0. Okay, there are certain constants a, b, c, and you need to find out the values of these a, b, c for which this particular function is continuous at x equals to 0. And the function is like this, that is sine of a plus 1x plus sine x by x when x is less than 0. When x is equal to 0, it is just c, some constant c. And when x is greater than 0, then the function takes up the form x plus bx square to the power half minus x to the power half by bx to the power 3 by 2. Okay, so these are the three parts of the function, that is when x is less than 0, when x is equal to 0, and when x is greater than 0. Okay, now how do we start? Okay, now if you look at this, that when at x equals to 0, the value of the function is c. As you can see here, when x is equal to 0, the value of the function is c, and this is what has been written, that is the value of the function at x equals to 0 is c. Okay, now for x less than 0, okay, that is your left hand limit, this is the part of the function which we are talking about, that is sine of a plus 1x plus sine x by x. Okay, that is x tends to 0 minus. Now minus indicates your left hand limit, and if I want to change this into, see, I mean it is like x is equal to whatever your a minus h. Okay, a is the number to which the limit is tending towards. Okay, now if I want to and in this case your x would be equal to 0 minus h. Okay, and h is an infinitesimally small number, so it doesn't make much of a difference. Okay, see, supposedly my a is just 0, okay, and h is too small, it is too small, that is, say h is say like 0.000000001, like this. So how far does that make a difference, in case even if I'm adding this to 0 or subtracting this from 0? So it doesn't make much of a difference, and hence I can write your x is equal to a minus h, or x is equal to 0 minus h. Okay, so because it is a left hand limit, in case if it would have been a right hand limit, then I would have written it as x is equal to a plus h, and in this case when a is equal to 0, I would have written it as 0 plus h. Okay, so limit of, and the entire thing tends towards 0. Okay, that is h tends to 0. Okay, now you have this, so wherever x is, you will be writing 0 minus h. Okay, see, wherever x is, you were writing a minus h, but a is equal to 0, so wherever x is, you're writing 0 minus h. Is this clear? Okay, so wherever x is, you are writing 0 minus h. Okay, your function was sine of a plus 1x, so in place of x I have written 0 minus h, plus sine x, so in place of x again I've written 0 minus x, upon x I've written 0 minus h. Okay, so this is the case. Now what are you going to do? Well, if you take it like this, now 0 minus h means what? Sine of 0 minus h is actually equal to minus, sine of minus h. Okay, 0 minus h, it means minus h. But you also know this, that sine of minus theta is equal to minus sine theta. So it is minus sine of h, and this is what I have written out here. Okay, similarly you have sine of a plus 1h. Okay, so sine of a plus 1h, and here this also becomes what? This also becomes sine of a plus 1 minus h, because 0 minus h means minus h, so this minus again will come out here, because sine of minus theta is minus sine theta. Okay, so now what could be done? Okay, so I have taken this minus sign common, and you will have this plus out here. Well, one thing which you guys know this, that if I want to use the limit of x tends to 0, sine of x over x equals to 1, I need to have this theta and this theta to be same. Okay, so if I have my theta as a plus 1h, okay, so in the denominator also I need to have a plus 1h. Fine. So how will I have that? See, what do I have actually? I have this. I have sine of a plus 1h over h. This is what I have. Okay. Now I need to make this as a plus 1h only. So I'll multiply and divide by a plus 1. And this is what I have done. Okay. And this is what I have done out here. So it is a plus 1 into sine of a plus 1 h upon a plus 1 h plus sine of h upon h. Now this is simple, okay, because this h has automatically come out here. Now then I have just substituted these limits, okay, so then I have just applied these limits, and you know this, that limit of h tends to 0, sine of h over h would be equal to 1. And this is what? So I have put in the limit out here, so this becomes 1. Then I have put the limit out here. This also becomes 1 because limit of h tends to 0, sine of h over h is equal to 1. And this is a constant, so it will come out of the limit. And it is a plus 1 into 1 plus 1. So it is a plus 1 plus 1, which is equal to a plus 2. Clear? Now, when you have x greater than 0, then you had a different kind of a function. You had this. That is x plus bx square root minus root of x upon bx to the power 3 by 2 when x is greater than 0. Okay, so how do you go about it? So you have, now I'm writing 0 plus, okay, because this is what I want to emphasize on, that when you're writing it as a right hand limit, so you'll be writing it like this. And you also know this, that you can write it as x is equal to a plus h. Here in this case your a is equal to 0. Okay, h is infinitesimally small number, so it doesn't make a difference. Infinitesimally small number would mean that h is almost equal to 0. It doesn't make a difference whether you add or subtract h from anything. Okay, so, and since x is equal to 0, so you're writing it as 0 plus h, and h, when h tends to 0, this x is tending towards also 0. Okay, so wherever x was, I've written 0 plus h. Okay, so wherever x was, I've written 0 plus h. So x plus bx square to the power half minus root of x upon bx to the power 3 by 2. Okay, so in place of x I have written 0 plus h. Now 0 is redundant, so I have written just h, plus b of 0 plus h square. 0 is redundant, so I have written h square, minus 0 plus h root. 0 is redundant, so I have written root of h, upon b into 0 plus h to the power 3 by 2. 0 is redundant, so I have written bh to the power 3 by 2. Now, the point is that you can probably take root of h common out here. Okay, so you can take root of h common out here, and how will you go about it? See, what do you have? You have h plus h square b to the power half minus h to the power half. Okay, now if you take h common from here, what will you have? You will have 1 plus bh whole to the power half minus h to the power half. Okay, so this is h to the power half plus 1 plus bh to the power half. So I've taken just h to the power half common, so I have what? 1 plus bh to the power half minus 1 upon b into h to the power 3 by 2. Now h to the power 3 by 2 could be written as h to the power half into h. See, 1 by 2 plus 1. It is 1 by 2 plus 1, which is 3 by 2. Okay, so h to the power 3 by 2 is written as like this, that is h to the power half into h. So this h to the power half and this h to the power half is gone, and I have been left with just this. Okay, now you also know this, that you have the limit of your x tends to 0, x to the power n minus a to the power n upon x minus a is equal to n into a to the power n minus 1. This is what you have, and this is the limit which you want to use here. So if x is actually equals to 1 plus bh, okay, so I need to have 1 plus bh as x here in the denominator also. Okay, so I'd be writing, I'm adding 1 and subtracting 1 from here. Okay, I can even write, and I need to have the same n here. So if n is half here, I need to have n to be half here also. But 1 or root of 1 or any indices of 1 will give you 1 only. So I can write this as root of 1. And this is what I have done. Okay, so this is actually equal to n. This is actually equal to x. Okay, and this is a. Okay, this is a. This is a. This is not a. This is a. Okay, this is your x. This 1 plus bh is x, 1 is a, half is n. So I've written it as, using this limit, I've just applied the limit and you got this. That is 1 by 2 into 1 to the power half minus 1. So you'll get as 1 by 2. Okay. Now the point is, if this function was continuous, then your left hand limit is equal to right hand limit is equal to f to the power 0 for continuity. This function needs to be continuous. Okay. Now it is a plus 2 is equal to half. You got this. This is your left hand limit. This is your right hand limit. Okay. Oh, I'm sorry, this spelling is wrong. And u. Okay, so it is left hand limit is equal to right hand limit. Should be the value of the function at equal to c. Okay, so half equal to c would mean that c is actually equal to half. Now this a plus 2 is equal to half would mean that a is equal to minus 3 by 2, because in case if you put this equal to half, the b would be any other real number. Okay, so these are the values of a, b, c in this case. Clear? Thanks.